Hi, good morning. It's Ask Dr. Ben. Let's do a couple little updates from the papers that are out today. Okay, so the first one is a paper that's coming out of Korea, or rather a preprint. These are all preprints, so this is looking at what's going to be coming down the line, but yeah, not part of the scientific record yet. First one is out of Korea, and they looked through, like I know so many other labs are doing, they looked through all the things that are FDA approved, and they actually tested out a lot of these in cell culture to see whether or not they could actually stop the virus. There are a lot of people doing computer modeling where they're trying to see if it looks like these drugs could potentially lock on to some part of the virus. But it's much better to do the test than to just do the computer modeling behind the test, because it's fairly quick and you can find out. And there are a lot of things that can go wrong. Basically, the drug has to bind to pretty much only one target on the virus and nothing else in the cell. And the cell is a very busy, complex place. So most of the time, there just isn't enough of the drug that actually does what the computer models suggest it could do. It's just getting tied up doing other things that are maybe a little bit easier to find or more likely for some reason or other. So yeah, fine. Anyway, what they come up with is two things that work really well. One is called Nafamostat, and that's one we've talked about before. That is an inhibitor of the protein cutting enzyme that actually activates the spike protein. And it doesn't just inhibit that one, it inhibits some other ones, which is why it's normally used as a treatment to block coagulation, if I remember right. Because that's going to be driven by another protein cutting enzyme. It's going to do one of the really important steps there. And so, yeah, that looks like it can work. And yeah, it's something that I think is either in trials or about to be in human trials. It's worked in cell culture. I guess you'd want to see it tried out in animals first. And it would surprise me if somebody is not already working really hard on that. It just takes a couple weeks to do the experiments, to go all the way through. Because, yeah, the virus is slow. It takes a while for the mouse to get sick and then to get better, if it does get better when you treat it. And then you have to do all the sectioning, cut up each of the little organs and see what the virus is actually doing in there. So to demonstrate that you're actually having a direct effect on the virus. But it's positive. The other one that they mention is called, I think you pronounce it Wabane, and it is known as an extreme poison. It causes heart muscles to just start beating crazily fast, and so it is not a good thing. So we know that COVID-19 involves a lot of damage to the heart, and so even if this is effective against the virus, they're not doing tests in an animal right now. They're just doing tests with cells, and they're not heart cells. So it looks promising, but it's probably not promising at any dose, just because there's already a lot of stress on that particular system. So there we go. That was our first little bit, and thank you very much. This is Ask Dr. Ben.